Having already covered similarity for lengths and then looking at how we used our length scale factor to find our area scale factor, we'll now move on to our volume scale factor. In order to see how we can take our length scale factor and convert it into a volume scale factor, we'll look at some enlargements. Over at this side here, we've got the original shape, which I've just drawn out 3 cuboids with dimensions 3 by 1 by 2, and I've performed 3 enlargements here by a scale factor, and we can see how our scale factor for length compares to our scale factor for volume, very similar to what we did with area just recently. So if we start to look at the first shape here, and we can start to write in its volume. Remember, the formula for volume of a cuboid is length times breadth times height, so that's 3 times 1 times 2. That gives us a volume of the first one of 6 cubic centimetres. And with the second one here, we have dimensions of 6, 2 and 4. So our volume is going to be 6 multiplied by 2 multiplied by 4. So 6 2s are 12, times 4 is 48. And again, that is cubic for cubic centimetres. So once we've done that, we can start to compare our sides in order to get our enlargement scale factor for length. So let's just take the bottom side on both cuboids there, so the 3 and the 6. And as this is an enlargement scale factor, what I want to do is write that out as a top-heavy fraction. Remember, I need the fraction to be bigger than 1, so using the 6 and the 3, it's going to be 6 over 3, which will simplify to 2. That makes sense. It's 2 times as big. I've got 3, and I'm multiplying that by 2 to get 6 for the length. For volume, I'm then going to compare my 2 volumes here. So what I can do maybe is look at the 6 cubic centimetres and the 48 cubic centimetres. And we can see here that if I want to convert that into a scale factor enlargement for volume, again, it's going to have to be the 48 over 6. Now, 48 divided by 6 is 8. So that gives us an enlargement scale factor for volume. Again, as we're going through, what we're looking to do is look for the relationship between our scale factor of length and our scale factor of volume. So comparing these two numbers and comparing these two numbers and seeing how they're related. We'll continue to go through these very quickly, as we've already done this with area. We'll take our 3 here and our 9 here and quickly write down our scale factor for length for the second enlargement. And remember, an enlargement requires large over small, so 9 over 3, which 9 divided by 3 simplifies down to 3 again. Makes sense because the length 3 multiplied by 3 would give me the length 9 on the other one. We're also going to fill in very quickly our volumes. So again, this is not going to change. It's the same cuboid as above, so 6 cubic centimetres. Second one here, calculation, the enlargement. The dimensions are 9 by 3 by 6, so we have to multiply our way through that. So 9 times 3 times 6, and that comes to 162 cubic centimetres. And again, what we're going to do is we can compare our volumes there to get our volume scale factor. So 6 here and 162 cubic centimetres over here. Again, because it's an enlargement scale factor, it's going to be the larger number at the top, 162 over 6. And if I divide 162 by 6, I end up with 27. Once again, we're looking for the relationship between my 3 here and my 27. See if we can see a connection between these numbers, which is similar to the connection between the 2 and the 8 here. Very quickly, we'll go on to the last set of cuboids, and we'll stick in our information here. So again, the small cuboid is going to have a volume of 6 cubic centimetres, and we're going to have a look at the dimensions of the larger shape here, which I think is 12 by 4 by 8. So just remembering, volume of a cuboid is length times breadth times height, so that's 12 times 4 times 8, which comes to 384 cubic centimetres. So starting to compare our various parts here, we have lengths of 3 and 12 down at the bottom here. So our enlargement scale factor for length is going to be 12 over 3, which simplifies to 4. And for the enlargement scale factor for volume here, we're going to be looking at the 6 and the 384. So quite an enlargement there. We'll very quickly put those into my scale factor. Again, bigger over smaller, because we want a number bigger than 1, so 384 over 6. And if we divide 384 by 6, we end up with 64. So like we did with area, when we looked at area scale factor, we're going to have a look at these numbers here and see if we can find a connection between our scale factor for length and our scale factor for volume. So how is 2 connected to 8, how is 3 connected to 27, and how is 4 connected to 64. Now if you look at this, hopefully what you'll soon see is 2 times 2 times 2 is 8, or 2 cubed is 8, 3 times 3 times 3 is 27, so 3 cubed is 27, and 4 cubed is 64. So basically, if I want to get my scale factor enlargement for volume, all I need to do is cube my scale factor for length. This then brings us on to the type of problem we're likely to encounter in an exam. So we must know that to enlarge or reduce a volume, we must cube the linear scale factor. So let's have a look at this first question here. So 2 sauce bottles are mathematically similar. The larger bottle has a volume of 700 millilitres. What is the volume of the smaller bottle? So straight away here we're trying to get an idea for the enlargement or reduction scale factor. And we've really got to ask ourselves first of all, is this an enlargement or a reduction question? Now, it tells me here the larger bottle has a volume of 700 millilitres. So that's this one here is 700 mils. And I want to find the volume of this one here. So I'm going to need to take the 700 mils here and multiply it by a scale factor for volume. So will I want that scale factor for volume to take that 700 mils for the larger bottle and reduce it or enlarge it? Now, because this is the bigger bottle, 700 mils, I want to reduce that 700 mils to get the volume of here. So this is going to be a reduction question. So I'm going to start off with reduction scale factor. And because I have lengths given to me here, and these are the 2 numbers I'm going to use to make up my scale factor, the reduction scale factor I'm going to have to start with is a reduction scale factor for length, because I'm using lengths to create it. So a reduction scale factor, remember, needs to be a number less than 1. So if I'm going to be using the 19 and the 28 here and putting them into a fraction, I need to make sure that fraction is bottom heavy and therefore less than 1. So rather than 28 over 19, it's going to have to be 19 over 28. If it was 28 over 19, that would be an enlargement factor. Now what I can't do is I can't use this scale factor to reduce a volume, because this is a scale factor for length only. I could use it to reduce a length, but not a volume. So the next thing I need to do is use this to create my reduction scale factor for volume. And remember, as we discovered on the previous slide, our reduction scale factor for length, if we cube that, we end up with a reduction scale factor for volume. Now I don't need to work out what that is, I can leave it in that form as in 19 over 28 in brackets all cubed. What I can then do is just state the smaller bottle is equal to 700 mils, which is the volume of the larger bottle up here, and 700 mils multiplied by the reduction scale factor for volume, so 19 over 28 all cubed. And that's going to go into my calculator exactly as I see there. So that's going to come to 218.7 millilitres. And that's basically it.